Hello, in this video I'm going to be looking at this Ferguson Vidicon 3V20 camera from 1981. This is a Ferguson version of the GX88 JVC camera. It's a single Vidicon tube camera using JVC's step energy colour decoding system. The main difference between this and the JVC version is that the microphone's been moved up here as opposed to down here on the handle on the JVC. When I first turned this camera on, I was getting what appeared to be just a black screen. If I pointed it at a light, I could just about get a vague blue outline of the shape of the light. After warming up for a while, the camera now comes on properly with a picture, but it's very poor, as you can see in this footage. Main problem's this stretching of the image towards the bottom. This is actually the effect of the inverse happening in the camera, vertical scan being compressed at the bottom. But the picture's also generally not very good. From way this has progressed from barely working at all to working more of a time as it's warmed up, I'm expecting this to be capacitor problems. And I'm expecting to probably find leaky capacitors all over in this. So let's open it up and have a look inside. Another difference between this one and the JVC is the way these work. How they're spring loaded, so they pull back in on this, where on the JVC if you click that up it stays up. That makes this one a bit more awkward, because you need these to be up when you're looking at it, because one of them just basically blanks the picture off. I can see lots of leaky capacitors already in here. You can see this, as I suspected, it is full of leaky capacitors. That one. That one there. That one. Is that one leaky behind that coil? That looks like that one. That one. Is that one? Looks like that one's leaky. That one a bit. This one over here. And that's the video board. Have a look at the deflection board. Harder to see. They're all kind of bunched up. I can't really see them on the deflection board, or they're not visibly, leaking electrolyte out, but that doesn't mean that they're alright. This is the vertical deflection circuit. This capacitor charges up through these resistors, and the voltage at this point rises at a rate determined by this potentiometer here, which is the height control. This transistor is connected across the capacitor, and that's driven by the vertical pulse from the sync generator chip. The pulse turns it on, which discharges this capacitor at the end of the field scan, and then it turns off to allow the capacitor to start charging again, so you get a repeating ramp. That's fed to the non-inverting input of this op amp, and then there's these output transistors and the scan coils. So we'll have a look at these waveforms on scope and see what's happening. So that's the non-inverting input to the op amp. That's the inverting one, which is the same as you'd expect. This is the output. You see how it comes up, and at the top, rather than carrying on straight up, it just starts to flatten off a little bit, and that'll be what's causing that problem. Now you can see that these are sort of thicker, like as if there's noise on them, but what that actually is horizontal rate, an horizontal rate signal added into the vertical. And if you look at the horizontal signal, you'll see that there's a sort of a vertical rate element to it. Right, there's 3 electrolytic capacitors in this circuit. This one, and this one. So I don't know which one it is that's causing it. If it is one, I think it probably is. So I'll just try one. I'll try this 10 microfarad one. I've replaced that capacitor. So let's have a look at output signal now. And that's looking a lot better. It's not flattening off like it were before. We'll see how that translates to the picture. Well, you can see it's already a lot better. That stretching at bottom's nearly gone. That curvature at top's gone as well. There's still a little bit of distortion at bottom, but it's a big improvement. Well, we can see that capacitor is now good. The capacitor is 4.6 microfarad. And look at that ESR, 0.14k. 140 ohms. V loss 12%, and it's clearly no good. So I think I might check them other 2 capacitors that are in that circuit and see what they're like. This is that 100 microfarad capacitor I'm taking out. ESR 4 ohms. The capacitor is only 48 microfarads. V loss 6.8%, so that, you can tell that's bad. This is 4.7 microfarad one. 53 ohms. That's bad and all. I've replaced them other 2 capacitors, and this is the picture that I'm getting. You can see that deflection problem's gone, but there's another problem that's appeared. If we let a lot of light in, then we get this sort of purple and green picture. That sort of picture can be caused by beam current being too low, but I don't know why it's just started happening now after I've replaced them capacitors, because they're nothing to do with beam current circuit, I don't think. But it might just be a coincidence that it's appeared now. But that problem must be related to me putting that new 100 microfarad capacitor in, because I've just changed it back to old one, and as you can see that problem's gone away, but the vertical stretching at bottom's back. So I don't know, maybe that capacitor's dodgy, or I'm not sure. It's strange. I'll give that capacitor a test, and I'll try a different one and see. There's nothing measurably wrong with that capacitor by the looks of it. It looks alright. So I'm not sure what the problem is. That's a 35 volt one. I've got some 25 volt ones, which is what the original one is. I'll try one of them and see if it makes any difference. Right, I've done some further testing, and I tried putting a 47 microfarad capacitor there, because the capacity of that one were measured at like 50 odd, so I put a 47 one in, and that got rid of the thing. It was back to how it were with the old capacitor in. I measured the this on the scope, and there's a parabola waveform there, which is, you know, going to this vertical parabola pot there. With the old capacitor in, you got quite a big waveform, about 10 volts peak to peak or something, but with the new one it's down to sort of 7, which I suppose you expect because it's like bypassing it down to 0. It's connected to this, and the other end of that is that tantalum capacitor going to there, and there's this 220 microfarad capacitor here. So I'm going to have a look at that next and see if, I'm thinking maybe, I don't know, this one's gone bad, but that one going bad in tandem, as they've sort of cancelled each other out maybe, I don't know. It's a bit strange, but I'll look at that one. Well, this is that 220 microfarad capacitor. As you can see, it's pretty much fine, there's no up with it. It's one of these blue ones, they don't seem to fail like them little black ones. These are ones that fail. You see these little black Panasonic capacitors in a camera from early 80s. You can almost guarantee one of them will have something up with it, or probably loads of them. Well, looking at that difference here between them waveforms with the two different capacitors in place, and I thought, I wonder if I adjust this height control, if I can make a difference to that. So I adjusted it, as you can see it fixes it. That's lowering the height, but it doesn't make any noticeable difference to size of that waveform there. But I'm thinking now perhaps someone's had a go at it, at the camera, and tried to compensate for that reduced scan, that compressionate scan at the bottom, by increasing the height maybe at some point. I don't know, but anyway, it seems to fix it. The reason why that misadjustment at height causes that effect, I think it's probably because the black mask that's used for setting the optical black level, and like the AGC and everything, on these sort of tubes is at bottom at it's cross bottom at target. So if the scan's too big or too small, the scan's not going to be where it's expected to be on the faceplate for when the camera's setting its levels up from it. It'll cause everything to be out, which I think that's the mechanism by which that fault are happening. Right, so now that problem's solved, I'm going to go through and replace any other dodgy looking capacitors, like this one here. There's quite a few on this board, you can spot them quite easily. That one, it's green. This one over here. Probably, I think it's most of them on this board, and there's still a couple on deflection board that don't look very good as well. So we'll see where we are after that. Right, that's the capacitors that I've replaced on that camera. It's most capacitors on video board and a few on deflection board. You see how that leg's all corroded from electrolyte leaking out of it. I've done ones that are obviously like that. It's been a lot worse on video board than on deflection board for some reason. The blue ones on deflection board look at least alright, and that 220 microfarad one that I measured were fine. So hopefully they're going to be alright. I'll try it camera again and see how it is now. So this is it now after changing all them capacitors. Seems alright. They're just right. That. have to do a proper setup on it. It's looking alright. See that it overreacted to went purple for a second. Reduced the height a little bit more. It's a bit green looking. And there's definitely some bit of like bad focus near them edges there. Right, I'm going to do setup for this camera now. So I'll show you what I'm using. Which I've got a camera on this tripod pointing at that white sheet. Let's be A3 piece of paper. With these lights pointing at it. So that's what I'm looking at. Capturing it on here and also using that as a monitor. I've got the scope set up there. I've got another camera pointing at that. So hopefully you should be able to see what I'm doing on camera, the scope and the image, but for some parts of it you won't be able to see the image because I'll have to use the video out as the input to the scope. But underneath that I've got this grayscale chart, so I take that down when I need grayscale chart, and they're the main things that you need. There's also a red filter that you need for monitor adjustments. I'm going to start doing the setup now. Before you start it, there's some preset adjustments given in the service manual. Now I'm not going to do all of them. It's more, say if you've changed the tube or if camera's completely out of whack, but there is a couple that I'm going to do, which is the white clip, which turn that fully up, and the chroma limiter, which turn to centre. I'll do first adjustment now, which I don't need the lights on for this. I need the iris shut, and I'm probing test point 1 with scope set to 1x. And I'm setting the target voltage for a reading of 25 millivolts on scope. That's the dark current. You have to let the camera run and warm up, come to full temperature before you do that, because that dark current varies with temperature, so you want it to have sort of stabilised before you make adjustment. So the next one I need light on for, because it's the beam current. I'll set that to 10x. It's same test point again, but we're horizontal rate now. And what I need to do is open it fully up. And set this for 1.2 volts peak to peak. It doesn't need increasing that much. It's this bias part here adjusting. That's that set. I'll close iris again, and then redo the target voltage. Because that's affected by that. So next adjustment is horizontal width and horizontal linearity. But before you do that, you have to do a rough adjustment at focus. This is moved to test point 8 now, which is over here. A bit awkward to get to because it's behind all these wires. But there we are, that should be alright. I actually need it on test point 1 first to set the iris. Looking for 300 millivolts. Like that. So to do this, loop beam alignment as well, even though it's probably alright, but I'll show you how it's done. Change it back over to test point 8. But you're trying to get this sort of as flat and big as you can, which is already pretty good actually. But I'll just knacker it up and then redo it. So you're sort of setting them about 150 degrees apart, these two rings. Then you turn them both together. To get maximum amplitude, which is somewhere in that, and then turn the outer one on its own to try and, in conjunction with adjusting focus pot, to try and get it as flat as you can. That's the effect that it has. And I think that might be about as flat as I'm going to get it. So then for the width and linearity, I think it's test point 2 that we need. Preset these horizontal parabola, which is that one, full anti-clockwise. Horizontal tilt, full clockwise, which is that. Vertical tilt to mechanical centre, is there. Vertical parabola, full anti-clockwise, with that. So width first, and what you're trying to do is get this waveform small. I'm using a matchstick to turn this, if it is turning it, yeah. I can see that's making it bigger.
that where it goes right sharp and small. I think that's the right setting. Horizontal linearity 1. This is to try and get it sort of straight. Which it already is more or less. If I zoom that right in, that's a bit better. So that's straight apart from that curve that it's got to it. Horizontal linearity 2. That's for like neatening up edge, the left hand edge. And it's back to focus again. That's about as good as that's getting, I think. And you just the horizontal centering, try and make it symmetrical. Camera off and on. Can't really get it much better than that in terms of symmetry. Mounting position at deflection tube, I'm not going to do. Right, so next adjustment is the height. So I've got this 4-3 square, well rectangle, printed out, and I need to adjust it to get it to fill picture horizontally, like moving camera so that it fills it up. And then adjust the height suppose it fills it vertically as well, which is what we've got. Right, so this is the vertical centering. So what you've got to do is make it so that this, where it comes up, which is like the start of the picture, is 15 lines from here, which is the end of the vertical sync. So each one of these pulses is like half a line. So what I'll do, use the delayed sweep mode. Right, so we go 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm still getting used to this scope. I've not had it very long. Still getting used to how to operate it. It wants to be like that one division front thing. Have it there like that. And that should be that. Right, colour tilt compensation. That's set to 300 millivolts, and then it's these tilt and parabola controls. We'll do horizontal one first, I think. Set the tilt so that the discoloration's same on both sides. I don't think this pot's very good. And there's like that, and then there's a little thing. Then you set the parabola so that there isn't any what do you call it? It's kind of easier to do it if you misset the parabola, and then do the tilt. I can see now it's about equal. And then adjust this. Get rid of it. Should like that, I think. And then same with vertical. Vertical tilt. That's about right, I think. You still see, there's still got these bits of discoloration in corners that may not be able to fully get rid of. And that's the end of the deflection system adjustment. But what you do then is you go back through and readjust it. So that's what I'm going to do. Well, I'll not record it because you've already seen it, but it's just going through the thing again, sort of fine tuning it. Now that everything's roughly set up, having set up the things further down the chain, you can set up the earlier ones better and work through again and get everything a bit better. And hopefully I might be able to get rid of that discoloration in corner, but I don't know, mate, I might not be able to. Right, do signal system now. And first thing to do is the optical black level. Now this is a bit weird because if I turn it, you see that bit moving, this here, you set it level with this line, but normally you wouldn't have this little dip here, so it'd be set there, but what it says in the manual as well is that it should normally be set fully anti-clockwise unless the tube has image retention. That's the words that it uses, and that's it fully that way. And to get it level with that, you have to put it slightly off. So I'll try it like that anyway, so it's level with that. And I don't know about this little bit here, but it's something we can come back to if it turns out that it causes problems. Right, so next one is the AGC. Set up the AGC, and for this you need this, which is a 10 microfarad capacitor and a 56 ohm resistor. And I've got a couple of like crocodile clip leads to attach it. So the resistor end goes to test point 7, which is this one. The capacitor end goes to test point 6. Let's set R293 to mechanical centre. That's that one. Looks like it is already set to mechanical centre. So you have iris closed at first. Turn R206. So that pulse is level with that basic line. Which is there. And turn switch to auto and set it so that these 2 points don't move apart from each other. So like if I set this over here, they slip away from each other. Kind of hard to see, like see that. You need to make it so that I'm putting my hand over lens to sort of make AGC operate. So I'm making sure that they stay together, them 2 points, which I think they are doing. Yeah, the AUC seems to be working alright. I remove this jumper. Well, adjustment of Y balance brackets Y gain and Y gamma. Make a rough adjustment of the Y setup level first. Right, so this is where I'm going to have to use the video out. So you won't have video. Got another little jumper set up here, which is a 75 ohm resistor to terminate it. Okay, so it's 50 millivolts. Which it looks like it more or less is, almost. But it's 40 from there to there. That's when it's got iris closed. 255. Right. Yeah, that's about right now. A tiny tweak. Right, so now the Y gain and Y gamma. First set the iris for 0.4 from white peaked to optical black. That's optical black there. 1, 2, 3, 4. And then video out again, and I'll just adjust chroma limiter to make it a bit easier. It wants to be 0.7 volts from pedestal, which is that, to top. 1, 2, 3, 4, 5, 6. That's that. And this sort of crossover point wants to be halfway. 1, 2, 3. Yeah, it pretty much is. So that's alright down there. And proper adjustment of the Y setup. It's probably still fine. Yeah, it's changed slightly, hasn't it? Parts of it dodgy, I think. That's right. Right, so it's colour phase and blue matrix set up now, and this is where this red filter comes in. So I have to attach that to the front of the screen, front of the lens I mean. Test point 3. I'll need to take this stuff off, sort of shielding stuff. Let's test point 3 there. Turn this transformer to minimise noise and make the waveforms clearly visible.
it says, and then turn it. Another 90 degrees. The waveform's clearly visible there. That's it, the waveform clearly visible. And turn it another 90 degrees. Which is that. And so I haven't done presetting PW bit white balance VR. Unlimited to mechanical centre, that's right. PW balance VR to mechanical centre, that's R203. That's mechanical centre. 258 G matrix to mechanical centre. And more or less in the preset positions anyway. R276 B matrix full clockwise, that's that. Yeah, this is how it comes, how it is on image, with it upside down like that. That's it, with noise minimised. And it says to turn it another 90 degrees. That's that in it. Blue matrix leftward until the waveform amplitude reaches 0 below the basic line. Do not turn for leftward excessively. That's that. Adjustment of G matrix in G setup, test point 5, which is this one. Red filter still attached. R286 G setup, so that the AC axis average 0 level of the waveform coincides with the basic line, and then R258 so it's minimised. R286. Yeah. That's that. R258 so it's minimised. Yeah, that looks right. And white balance. I can take this off now. And this is going to be video out again. Right, so first it's a rough adjustment of the carrier balance. Which this is probably already fine. I'm trying to minimise the carrier. that's that. And video output. That's it, must be 0.9 pedestal to white peak. Turn chroma limiter down in order to do it. Finally, just R256 G matrix to minimise the carrier amplitude at the B portion, which is the middle. That's that. Finally, use R286. Minimise carrier amplitude of A part, which is bottom. And 305 R minus Y and Y minus B gain to minimise carrier amplitude at B. That's it. Then R203 peak white balance, amplitude, minimise amplitude at C.
little bit better than that before. Maybe not. You can tweak and tweak and tweak. As good as it's getting. Carefully check also the white balance of the picture on the monitor. See how it looks after doing all that. It looks alright. Let's that off again. Back to video out. The carrier balance actual adjustment, which I think don't even need doing. Just check it. I don't think it's gonna. Well, I'll give it a twiddle, but I don't think it's gonna get any better. Adjustment of chroma limiter and white clip. Turn the chroma limiter so that carrier above 0.8 volts is suppressed. 2, 4, 6, 2, 4, 6, 8. Well, that bit there. And then the white clip, adjust the peak value to 0.8 volts. This one. That. Adjustment of the auto iris. Put that on auto and set it for 0.67 volts. Adjustment of the burst gain, chroma gain and chroma gain balance. Set R363 chroma gain and R416 chroma gain balance to the mechanical centre. With the lens cap on, set the burst level to 0.3 volts. That's that in the middle. 416. That. Put that in the middle. And strap on, set the burst level with 0.3 volts by adjusting burst gain, then we move on to 0.3 volts. Put that there. That's that. Shoot colour subject and have a look at it on monitor. That looks alright in terms of gain, chroma gain, saturation and that. There's like best hue, make a fine adjustment of R276B matrix if necessary. R416 balance. It's this one here at the front. Keeps coming out. It's kind of hard to tell just from this. That lets it go a bit yellow. It's alright, I think. 276. Really seems to be doing out. I don't want to turn it too much. Yeah, that looks alright, I think. And white balance. Check a white balance on colour reproductivity. If they don't look very good, then redo some of it, but they look alright to me. And there's auto white balance. Right, now that the standard white balance is set up, you set up the auto white balance. To do that, you have to keep holding it to the auto position, the switch under here, and adjust these two so that it stops hunting. Well, it's already not hunting, but you can see that's standard, that's auto. You can see that there's quite a difference. You need to minimise carrier as well by adjusting these. See, it's hunting now. This is just so you can make it really hunt. It wants to be the same as its standard position. That's standard, that's auto. That looks pretty similar on scope. I'll check it against the picture. That's standard, that's auto. Standard, auto. Standard, auto. Standard, auto. They're not exactly the same, but they're very close. I've found that you can't always get them exact. But that's close enough, I think. So the next thing that it says to do is back focus, but you don't really need to do that because that's only really if you're putting a new tube in, which I'm not, obviously. And then you just put it back together, and it says readjustment of the carrier balance, which possibly like closing these up makes a difference to it. Well, close them up and then recheck it, because it's these two pots down here. You can't really see them from there. They're down there, so it's hard to get to them. You have to fault board up to get to them. I'll put it back together now. Let's do that final checker thing. Right, I've fastened up the side panels again, so I'll do the readjustment of the carrier balance. Oh, so it has actually changed a bit. That'll be alright, I think. That's that. Right, that's full setup done. So have a look at what the video's like from it.
Back onto standard white balance now. Back onto standard white balance.